So let's summarize the parts of stoichiometry and how we can interpret reactions using this chart. We're going to call the left side of this chart the given side, and we're going to call the right part of this chart the wanted. You could say reactants and products, but we're not always just comparing reactants and products. Sometimes we're comparing reactants to reactants and products to products. Okay, so let's begin with the given side. On the given side, we can begin, you could be given a certain amount of particles or a certain amount of grams or a certain number of liters of gas. Our first goal is to change them into moles of that particular substance, so we're always working from left to right. And if you start with particles, grams, or liters, you got to gather all your moles first. So if you get to this point, you're going to have moles of given. This line really is the moles of given. We're headed right to this point right here. If you get to there, then you've gotten to mole given before we cross the mole bridge. How do you do that? Well, we know that if we want to change particles to moles, we're going to use Avogadro's number, and the conversion factor is in fact 1 mole over 6.02 times 10 to the 23rd particles in 1 mole. So that's our conversion factor to get from particles over to moles of given. If you start with grams in a problem, the first thing you want to do is to change it to moles by multiplying it by 1 mole over the molar mass, and this comes from the mole map part 1, in which we were only working with one particular substance. And then what we just showed in the last video was that 1 mole of a gas is the same thing as 22.4 liters of gas. So those are your conversion factors that go from where you're given to moles of given. Once we have moles of given, we looked earlier about ratios of moles from a balanced chemical reaction doing the stoichiometry. And so this becomes what I refer to as our mole bridge. Our conversion factor becomes moles of given on the bottom. That G stands for given. And let's put our moles of wanted on top. And so this is how we convert from moles of given to moles of wanted. Keeping in mind that this ratio comes from the balanced chemical equation. It is the mole ratio, and it's the coefficients as we find them from the mole ratio in that particular problem. I like to call it the mole bridge. So we're gathering all our moles. Now we're ready to cross the mole bridge to shift from one particular substance to the other. And then it becomes a matter, once I get to this particular point on my mole map, I now have moles of wanted if I'm here. So we're moving in this direction. I can convert to moles wanted using the mole ratio. Once I get the moles wanted, then I can change it into any of the other units that the question asks for or that's required in the lab. I could change it to particles, to grams, or to liters, and I just undo the moles. In this case, if I want to go from moles of wanted to particles, I multiply by Avogadro's number over 1 mole. If the lab or the question calls for me to convert to grams of wanted, then I just multiply by the molar mass over 1 mole. And if I need to get to liters, then we know the ratio is 22.4 liters for every 1 mole. Some things to be careful of when you're doing the stoichiometry. Your first step or the last step, make sure that we're always making this 1 mole all the way through. In the middle on the mole bridge, where I've got moles of wanted, moles of given, this could be 3 to 2, 5 to 4, 6 to 1. make sure that it's the coefficients that help you determine the ratio that you use in the middle. And so now that we've seen how the mole map works, we're going to go to the next video to show how we can do some examples of stoichiometry work, and then we'll get into the application of stoichiometry in terms of limiting reagents.